Okay, go ahead.
Okay, give me 1 second.
Yeah, for sure, yeah.
Okay, welcome to Cyber Wizard Institute lecture on SVG. So, in the last lecture we talked about DOM. SVG is an image format where we can use everything that we just learned about the DOM to make vector graphics. So SVG is a text-based image format that works with vectors. So you might see a bit of SVG code that looks like this. So here we have SVG. There's some code that we don't need to get into very much, but there's a view box, there's width height. There's this ugly XMLNS thing, but here we have a circle tag. So inside of an SVG block, we have all of these different tags that do things like draw circles, draw polygons, draw lines, triangles, whatever we want. So the circle starts at X position 300, Y position 200, radius 5, and the fill color is purple. So if you take that bit of SVG and you drop into an HTML file, like so, then we can have HTML like normal, SVG demo, but inside of the SVG block, we will see something different. We will see a little purple circle. So if I load svg.html, hang on a sec, that demo, right, to get rid of some things. There we go, we have a little tiny purple dot right there. So let's make that a bit bigger. If we set the radius to be something larger, like 200, there we go, big purple circle. So this is the circle tag. There's a lot more that SVG can do. So there's this kind of viewbox stuff. This just sort of sets the left and right and top and bottom extents. It's kind of handy when you need to implement panning and coordinates. But first, let's talk about attributes that almost every SVG element has. So some of the most common ones are fill, stroke, and stroke width. Fill, if we set fill, that's like the solid color. So in our case, for the circle, we could set it to purple, we could set it to orange. You can use hex characters with the hash sign if you know a hex code, so we could do that with hex, just like HTML normally does, bluish. We can set a stroke color, so if we do stroke equals pink, it doesn't do anything. If you look really closely, there's actually a really faint pink line. But if we do another property, stroke width, we can actually set how wide that stroke is around. So the stroke is the border, basically. So here's our border around our SVG. It's clipping a little bit at the top. But if we push our image down a little bit, there we go. So you can set a border around an image, you can set a fill color around the shape. This one's a circle, and you can also set the width. For circle tags, you have the center X and the center Y. So this is not the left top corner, it's actually the center of the circle. And the radius is the R attribute. Likewise, there's a rectangle tag. So if you do rect with like X and Y and width and height, then you can have a rectangle in your page. So if we paste that, in our case, we'll need to move it around a little bit. So we do maybe that. Oh yeah, one really annoying thing about SVG is you have to close the tags with this /greater than sign. This isn't weird XML-ism, but if you don't do that, then your other stuff won't happen. So be really aware of that. If your SVG stops working, sometimes it'll show up in the debugger console, but sometimes not. So just be really aware, like if I don't close that, it doesn't even show up. So if stuff isn't being weird, make sure that you are doing /greater than at the end of your rects and your circles and what have you. So rectangle, circle, these are fun things. There's also text. So just like HTML, we have ways of displaying text in our images, so we can put some text in our page. Unlike the circle and the rect tags, this one has a closing tag, so you have to do /text at the end. So if we add that to our text, to our SVG file, we should see some text. There it is, whatever. We can change the stroke and the stroke width and all kinds of fun stuff like that. So if I say text stroke, or let's just set a fill equals red. Now the text is red. We can set a stroke, that's like a border around the text. All kinds of fun stuff we can do. Okay, so there are some other attributes that SVG has. For example, there's transform, scale, rotate. There's also matrix, so if you want to actually hand code a matrix transformation, like perspective, orthogonal matrix, you can definitely do that if you know how. For now, one thing we can do is, so like our text, for example, if we want to translate, or sorry, if we want to do transform equals, we can do translate 0, 300. So that should put the text 300 pixels below where it normally appears at. So indeed, it shifts it down. If we do a translate of like 300, 0, it should push it off to the right. It does. We do some other kinds of transforms, like scale. We can make our text bigger than it would normally be. So if we want to make it twice as big in the y and the x, we can do scale 2, 2. Now it's twice as big. Still a bit off to the right. So here I'll just adjust where it is. There we go. If we want to squish it so that one coordinate is much wider than normal, and maybe the y coordinate is much shorter, then we can do scale maybe 3, 0.5. Now it's really flat text. There's other transforms we can do, like rotate. So rotate takes, I believe, an angle measure. Yeah, so it takes a number of degrees. So if we want to rotate our text, we can say rotate 20 degrees. It's rotated. We can rotate it the other direction. So let me just set the x back to where it was. So that's 20 degrees. We can set negative 20 degrees as well. It's like the other way. Fun stuff. There's a whole matrix. We can do all of the matrix operations with SVG tags. A really fun thing as well is if you have a collection of properties and you want to perform a transformation on all of them at once, you can use this other tag called a G tag or a group tag. So a G tag and a /G tag just sit around all of the properties, and it can have a transform, and you can do like a group transformation. So here, if we have our circle, okay, so we have our circle. It can be by itself, but maybe we want to transform our rectangle and our text all at the same time. So if we add a G and a /G around our rectangle and our text, now I can move this transform out of our text and into the G, and that will translate our rectangle as well. So transform equals rotate 20. So now both our rectangle and our text have been rotated. That's what a G tag does. If you want to do multiple transformations at once, you can just separate them by a space. So if we want to do a rotation and a transformation, rotation first, transformation second, we can do something like 150, 0. And then it will rotate and translate. Or transform. Translate, not form. There we go. Fun. Okay, so another fun thing we can do is SVG has this built-in path tag. Path has this sort of weird little sub-language in the D attribute. So if you create a path tag with a D attribute, it's sort of like G code almost. Like if you've ever seen a plotter, like this CNC right over here to my left, how that works is you have basically a little drill head, and you tell it to go down, and then you tell it to move around on the X and Y, and then you tell it to go up again. So SVG has a similar kind of thing where instead of a drill bit going up and down, it's sort of like a pen going up and down. So M says, okay, move to position 100, 100. L means start drawing from the previous position to 300, 100. All of these are capitalized. That means use absolute coordinates. If they were lowercase, they would be relative coordinates. And then the next one is 200, 300. So even if you don't quite follow all of that, if you copy paste this, so if we get rid of some of our previous stuff and we add a new thing, then we should have an orange path. And we do, and it's a triangle. So if we want to mess around with the shape, maybe add another point to it so that it has 4 sides. We could do something like L 350, 400. I don't know what that'll look like. There we go. It's an hourglass, kind of messed up hourglass. You know, it's more common to use a vector program to do paths and complicated shapes like that, or you can also generate these kinds of shapes from data sets. Like you can imagine if you had a line graph that you wanted to generate, you could use a path, or there's actually a more appropriate one called a polyline that's not closed, where you can set up a bunch of points that you want to render. So you can make complicated shapes. This is what graphing libraries like D3 are using behind the scenes. And it's actually pretty easy to make a graph with just straight SVG if you want. Okay, so here's some more about the path string syntax. There's move to we saw with M, and that takes x and y. There's also lowercase m, that's relative coordinates. There's a capital L, which is line 2, so this draws a straight line, and the relative counterpart, lowercase l. There's also curves that take like a bunch of parameters that trace out a curve, like with the Bezier points. And then z is closed path, which just means it's like pen up or whatever, or home. There's also some wackier ones that you don't see very much, like elliptical arcs, quadratic Bezier, and cubic Bezier, but I won't go into those because you should just let a tool like Inkscape handle that unless you want to be a math whiz and figure out where all of the points are. But okay, some more stuff. If you don't really like dealing, or you have a data set that doesn't lend itself to that sort of point G-code style syntax, you can use polygon tag. Polygon tag just takes an array of points. So there we go. So this points tag is just a comma separated list of coordinate pairs separated by spaces. So this is like x, y, x comma y space, x comma y space, x comma y. So we can take this polygon and maybe put it next to our path. So here we go. Let's clean that up. We'll probably want a fill color, or maybe a stroke color rather. So we can set the stroke on this polygon to purple and the stroke width to 5 so we can see it. And don't forget to put the slash tag on these or else they won't work. There we go. There's a little hexagon. If we want to make it bigger, we could of course use one of those transform tags that we talked about earlier. So if we do transform equals scale of 2, 2, then it will be twice as big. Or 5 times as big. Quite big. Fun. So that's a polygon tag. You'll notice that the polygon tag is on top of the path tag. That's because it comes after. So the order that you define the tags is the stacking order. So if I move this polygon up, then the path, the hourglass will be on top. There's also polyline. This is an open shape. So a polygon is a closed shape. So you specify like if you specify 3 points, then it will close the line segment between the last point and the first point. But if you use a polyline tag, it won't do that. So for example, if we take, but it takes a points array just like polygon. So if we change our polygon tag to be polyline, our hexagon, see right there, is missing, and it will be a little more clear if I put it in front. Our polyline tag is now missing the last line segment because it's not closed. So polylines are, I think they're pretty useful for like graphs and things where you don't want a closed shape necessarily. So we've been doing all of this with an HTML file right now, but fun thing, we can construct all of these elements dynamically with JavaScript, and then we can start doing some fun stuff. So before I get into constructing the documents, why don't we play around a little bit? So let's set our scale back to a little bit smaller so we can see what we're doing. So here is our polyline tag, right? We can do, just like we did in the last segment with the DOM, we can do document, oh my gosh, this console is kind of crappy. Document.querySelector, polyline, there it is. You can also right-click Inspect Element if you want to do that to see what you're playing with. So now we have a reference to this polyline tag. And look, this is just an element, right, with attributes. How do we set attributes on the DOM? Well, we'll just save, I'll save that to a variable called p, and I'll call setAttribute. So if we want to change the stroke color from purple to red, we can set stroke to red. Now it's red. If we want to set the fill color to transparent, there we go. If we want to rotate our polyline, so remember our P here has a transform that's just setting a scale. So if we do p.setAttribute transform, we'll keep the scale to 2 from before, but we'll also add a rotate 10 to rotate 10 degrees. It's rotated. Or negative 10 degrees, rotated the other way, or negative 40 degrees. It's sort of out of the view box, but as you can see, we can start doing some interactive stuff. So there's a handy API available when you're in the browser called setInterval that will repeatedly run an operation. So if we have an angle, like we'll set it to 0 to start with, and then we'll create setInterval. It takes a function as the first argument, and a time in milliseconds as the second argument. So if we want our function to run every 17 milliseconds, which corresponds to a frames per second of 60, approximately, then we can, instead of negative 20, we'll just use a string concatenation to set our angle. And then at the end, after we're done setting our attribute, we will do a plus equals 1. Now, as we wait here, it will start coming around and it's animating. We can do that as well with the other one. So if we set p to the document.querySelector path, I think it was. Yeah, so that's the, right, so that, we just set the hourglass now to spin around by rewriting the p variable. Anyways. You can do this with whatever thing you want. If you want to make custom animations in a page, setInterval is not the best way to do it, but it's a way to quickly get started. I'll show you a better way in just a moment. Okay, but if we want to do other things, like what if we want to dynamically construct elements in our SVG? So I'll reload this page. We'll be back to where we were. Unfortunately, you have to use this kind of wonky API called document.createElementNS. NS stands for namespace. And the reason for this is when you document.createElement, you're creating elements in the HTML namespace. But when you do this for SVG, you have to pass in this other thing instead. So basically, if you pass in, so if you want to create a circle, you call document.createElementNS circle, but then you have to pass in this ugly string like that. So we'll do that. So we'll add a circle to our SVG. Little demo here. So circle equals document.createElementNS circle. Whoops. Qualified names start name character. Well, I don't know why that's not working.
Right on the body.
Oh no, it's document.createElementNS. That's strange. Maybe it's that one first? I don't think so. Okay. That seems to have done it. Anyways. I guess I get the order backwards. Whatever. These tags, I never use these tags. I use a module instead because it remembers that wacky string. But we can do certain things like document circle.setAttribute radius. We'll set the radius to be 50. And we can do circle.setAttribute fill to be cyan. And now we can set the CX and CY parameters. So we'll set the CX to be 100. And CY likewise to be 100. Now if we document.querySelector for SVG, we get our SVG body, and now we can .append child circle. Yay, there's a circle. Great,
Wow.
that worked. So now we have a circle on the page. We can, of course, call setAttribute with the custom transforms. If we want to make it move around, we can do whatever we like. So it's a bit weird. These notes aren't actually correct. You have to give the URL first for some reason, I guess. All of the DOM nodes work, including setting all of the DOM methods, including setting .style. So you can actually style CSS, or you can style SVG with CSS, which is fun. So if I want to do circle.style.background color equals red, well, I think the fill is overriding that. But if I want to set another property, like, what can I actually do? So if I remove that property, remove attribute fill, and then I set the style to be red. I guess that doesn't work either. Well, anyways, you can set CSS attributes, but they're not always what you might expect them to be, unfortunately. Some other useful methods on all DOM nodes. This is true of all DOM nodes, not just SVG, but it's especially useful for SVG. You can call these elements clone node is really handy. So if you have a whole, like say you have a group, right? If we go into our HTML again, and we make a group around everything, we can give that group an ID. ID equals sprite. Now if I reload the page and I document.querySelector for hash sprite, I get this potentially sprite element. So one thing I like to do with SVGs is I'll create a bunch of sprites with Inkscape, which I'll show you in a moment, and then you can actually remove them from the document. So if we do document.querySelector svg.removeChild's sprite, now it's gone from the page, but we still have a reference to it. So whenever we want to create a new sprite, we can just do sprite.cloneNode true, which means recursive, I think. And we'll save that to a variable sp0 for sprite0. Now if we want to add that to the DOM, we can do document.querySelector svg, or we could save this to a variable as well, .appendChild sp0. It's back on the page. We could also sp0.setAttribute transform to be a translate 0. Let's move this one off to the right. So translate 300 0 and maybe rotate it by 10 degrees. That'll be fun. There we go. Okay, so that's one sprite. What if we run a second sprite? We can do that. So if we do sprite.cloneNode true again, and we assign that to sp1, now we have another sprite that is not the first sprite, and we can likewise append it to the DOM, just like before. So we have our SVG handle, we just call append child sp1. Now there's two of them on the page. So this is a really useful technique if you want to make things like a game, for example, where you might have a lot of characters running around and you need to just pump out copies of a common thing. It's also pretty useful for more mundane visualization tasks, like if you want to make a bar chart, you can just like have a bar and then you just sort of clone it and move them around and whatever you like. So that's a clone node. If you don't want to have to remember that awful document.createElementNS thing, you can use this package that I wrote, published to NPM, called SVG createElement. And it works just like the document.createElement, where you just give it a name. So if you do require SVG createElement, I'll just do this really quick to give you a demo of maybe what that workflow is like with Browserify. So if I make a page, I'll make a SVG create. We go into that directory. So the first thing you would do is npm install SVG createElement, and you would also do beforehand npm install -g browserify. Once you've done both of those things, you can start to write a file like main.js or browser.js or something. You can paste in that code, and then you can document.body.appendChild svg and document.svg.appendChild circle. And now just to make sure that we can see the circle, let's actually set some properties on it, like radius to be big, and CX and CY, and a fill color, finally. So, okay, and the fill can be pink. This might work. We might also have to set some of the CSS properties. Okay, so we are using this require method. This isn't native to browsers, but this is something that works in Node. So we run browserify main.js. We can pipe that into an output file, bundle.js, which is just a big blob of JavaScript that has everything we need in it. So it does that document.createElement ns garbage for us. We can then make an HTML page that just does script src equals bundle.js. And because we're using the document body, we'll have to make sure to remember to put a body in the page. Put other stuff too, like h1 hello. Okay, and this should create the SVG element automatically for us when we run it. So if I go to this directory in my browser, I click index.html, hello, and there's a bit of clipping, but there is our circle, our pink circle that we created dynamically with JavaScript and the DOM. Great. A nice thing about SVG create element is that you can actually do all of that stuff with a little bit nicer syntax. You can just specify an object, and so all of this set attribute stuff, you could write that as a little bit nicer, R50, CX 150, CY 150, fill pink. Just a very small amount of sugar that's kind of justified, I think. So that just does the same thing as we did previously. Okay, so if you want to insert an SVG into your page, you might think that you could just img src equals cats.svg, and that will work. So, but there is a caveat. So if I make a page.html, I have a pony.svg file. If I do here's a pony /h1, and I do img src equals pony.svg, then if I open up page.html, there indeed is a pony. This is a vector graphic. It's displaying in our browser and everything. But one problem is that when we do document.querySelector SVG, nothing is found. And if we do document.querySelector img, okay, there's img src equals pony.svg, but it's not like we can just interact with that pony. There's no, we can't do like query selector for G, nothing. There's nothing inside of that we can get at because it's being loaded with another URL. So if we want to actually load a pony and manipulate it, we've got to do something different. We've got to use XHR, which you might remember from our DOM talk. So with XHR, we can actually load the text content of an SVG and then render it. So we could do this, right? We could use the XHR module to load pony.svg. So I'll just show you how you might do that. If you copy paste this code, with a bunch of ugly document.createElement garbage, well, if we put this into a script tag, let's see. Oh, actually, we're requiring a module, so we can't even do that. Okay, so if we have a pony directory, we'll need pony.svg in that directory. We'll need a main.js where we put our code, so xclip-o, that's our code, main.js. We need to change cats.svg to pony.svg. We can get the request body from the XHR module, and then this will just give us the big blob of, we can do all of this wackiness with creating a div and inserting the SVG content. It's quite complicated, but it does work. So if we browserify main.js to be bundle.js, and then we make an, in our index.html, if we script src equals bundle.js/script, and make sure to have body and pony loading demo. Okay, so now we'll actually have to run a web server, because when you do XHR requests, that only works if you're in an actual web server. It doesn't work if you just have a file on your file system. So if your URL bar says file : / then XHR isn't going to work. So we'll have to, so here I'm just using this handy package that you can get by doing npm install -g xstatic. And you can just give xstatic a port with -p to listen on, so we'll listen on port 9000 on the current directory. So if I go now to localhost 9000, I see pony loading demo. Uh-oh, failed to load favicon. Okay, that doesn't, what error is this? Okay, so this didn't even work, which is okay, because I'm going to show you an even better way. So instead of wrangling with this kind of garbage that may or may not even work, there's a much better way. You can use this package on npm called load SVG. With load SVG, you just give it the URL that you want to load, and it gives you an SVG element. So it does all of the construction, it does all of the ugly crap inside of it. If we copy paste that into our main.js, and we'll modify cool.svg to be pony.svg. So if we run this code now, it should append the SVG to our body. So if I rerun browserify, and I rerun xstatic, and reload, hopefully, yeah, we have a pony, and it actually worked. And now, check this out. So remember how last time when we did document.querySelector for SVG, we got nothing. If we do document.querySelector for SVG this time, we get our pony, and we can do like another query selector, or we can access elements inside like a group. And we can do things like set a transform to be like rotate 10 on our pony, and it rotates, or -10. We can't see it very well, but it is in there. Let me just document.querySelector SVG. We'll just make the page, the view box a little bit bigger here, so it's a bit small. Oh yeah, we can just set the width and height, I believe. So if we set the width to be 2000, there we go. We'll set the height to be really big as well, because we're going to need some space. Okay, so now that we've made our SVG a bit bigger, let's save a reference to that G, because it just so happens that our pony lives inside of a G. So there it is rotated. We can now set attribute transform. We'll do a translate down a bit, because we can't see it very well, so we'll do maybe 100 pixels to the right and 200 pixels down. Oh, maybe a bit much, maybe 100 pixels down. There we go. Hello, pony. And we can rotate 10 degrees. There it goes. So, just like before, we can make a little loop for rotations. So maybe this time, instead of rotating all the way around, we'll have it rock back and forth. How would we do that? Well, we can make a variable, a, it's our angular measure. Let's see, if we take an angle, and we want it to oscillate between two values, so we can use sine for that. That wouldn't be an angle, but we can have a counter. We'll just call it I. Now, if we have a set interval, we can now set our attribute inside of that interval, and we'll make it run 16 or 17-ish times, 16 or 17 milliseconds between iterations of that loop. Now, instead of hard-coding that rotate, we can set that to be math.sine of I plus. And the pony is really flipping out. So why don't we reload that pony? There we go. Oh, I forgot the SVG part where I set the width and height, but let's just redo that really quick. So we got some space. Okay, so we got some space with our pony this time. Now, just like before, we can set attribute transform, but this time we'll actually take that I++ and we'll slow it down a little bit. So we'll take the I++ and maybe divide by 20 and multiply that value that it gives us so that we have a wider amplitude. So we'll maybe have 40 pixels of amplitude. And maybe divide by 50. Whoa, crap. We actually have to have a G variable. It just so happens that our loop is going to keep iterating, so if I just create it, then it will totally work. There we go. There we go.
Wow.
Pony's going up and going down and going up. So all that it takes to do that is just a little bit of using a timer with set interval and setting some variables and just some really basic DOM manipulation to set things like the transform property with a translation and a rotation. All you need is some simple variables, some simple math. You can make ponies jump on a page. It's pretty fun, I think. So another thing, I promised that I would talk a little bit about a better approach to using set interval. So if you have a more involved demo where performance will start to matter, then you'll want to use this API called window.requestAnimationFrame. Or there's a module in NPM called RAF that's quite good that I recommend. So how it works is when you call window.requestAnimationFrame, if you call that over and over again, then the browser is going to sort of throttle that and figure out the timing so that you're hitting about 60 frames per second if it can. If it can't do 60 frames a second, it will scale it back on slower devices, but the nice thing about this approach is, unlike a timer that might have a lot of drift, the browser is going to keep you in relatively tight time coordination. So if you have a more impressive, more performance-sensitive demo, then this is definitely the way to go. So how you might do that. Another important thing to note is if you're using requestAnimationFrame, you want to compute a time delta because not all devices will be able to hit 60 frames a second. And if you want your simulation to run the same across all devices, you should make sure to check to see how much time has elapsed between the frames. So here's a basic technique for how to do that. So I will just do a little demo here. Pop back out to directory. So I'll call it raf.html. Just do a little script in line here. So actually, why don't we just go back into our pony directory and we'll do this pony properly. Okay. So right now we're just loading the SVG and inserting it into the DOM, but what we could do instead is we could do window.requestAnimationFrame of a loop function. So here we'll have a function loop, and maybe we also want to save that that G tag inside of the SVG that contains all of the pony elements. So here we've got our requestAnimationFrame. Now our loop function needs to do some stuff, and then after, so here, do some stuff, but after we're done doing stuff, we can call window.requestAnimationFrame again with our loop function. So how this works is the browser isn't going to call our function right away. It's going to wait a while. It's going to wait about 16 milliseconds if it can before calling us again, and it's going to behave nicely with the rest of the scheduling that it needs to do. So let's do some other stuff. So just like before, let's have a counter. Let's set g.setAttribute transform, and then we can set our translate. I think we had about 100, 150, and our rotate. So in our rotate can include our I variables, so math.sine of I ++ over 20 times 50. Yep, question.
The question is, I still don't really get why you have to do window.requestAnimationFrame loop again.
Why we have to do it again?
Or inside the loop function.
So what I'm doing here is I'm actually doing a kind of asynchronous recursion. So if I just call window.requestAnimationFrame, the browser is only going to call my function once. So I have to call it again so that it will schedule my function to be called again when it can. Okay, so this should be pretty much our same demo as last time, but maybe a little bit faster because I couldn't remember offhand what the parameters were that we used last time. But if we run this code, hopefully it should work. So we run browserify and main.js to make bundle.js. We run ecstatic on port 9000. We reload the page. And oh, I remember what it is. We adjusted the SVG height and width before. So let me just do that real fast. So if I do svg.setAttribute width 2000 and the same for height, and rerun browserify and ecstatic, Yay, cool. So faster pony. This one is using request animation frame. So what we could also do is, just like the slides indicate, so now that we got that working with request animation frame, we can compute the time delta. We can use the time delta to adjust our timing so that it will work. It'll look pretty much the same on a really slow, maybe a phone or a tablet, and a desktop computer. So to do that, we can use date.now to get the number of milliseconds since the Unix epoch in January 1st, 1970, and we can subtract the last value that we got from the current value to get the delta. So inside of our loop function, we could say last equals date.now outside, and then bare now equals date.now. And the delta is going to be the now values minus the last value. And then after we've computed the dt, we can set the last value back to be the now value. So I'll just console.log what the dt is. It should ideally be around 16 or 17, but we'll see. Another trick is if you find yourself rerunning Browserify a bunch of times, you can use Watchify instead. It takes the same arguments, except for you do -o. So, and I'll add a verbose so we can see it when it's running. And I'll run ecstatic on 9000 in the current directory. Okay, so now we can just edit that file. Great. Reload. And if I look in the debugger, there we go. We're hitting a delta. It's kind of all over the place. Part of that slowness is because my computer is not very good. Another part is my computer is printing out all of these messages to the console, which is actually a little bit slow. So another thing we could do is we could set the H1 maybe to display the frame rate instead, so, or at least the delta time between things. So if I get a handle on that H1 tag, selector H1, we can now, instead of doing console log, do h1.textContent equals dt. There we go. It's hard to see because it's going fast, but it's doing a little bit better. The first digit is mostly a 1, which is good. And I see some 7s and some 6s, so that's pretty fast. Great. So how do we actually use the delta in our simulation? Well, we can, instead of doing just a counter that always increments at the same rate, we can incorporate the time delta between the last time that our simulation ran and the current time. So instead of doing I++, we could do I plus equals dt. And now we'll just do sine of I. I think that should be, and then we'll add a constant coefficient to slow it down a bit, because the dt is going to be about 17. We had a 1/20 before, so we want about 400, I think, offhand. We'll be around the same ballpark in speed. Anyways. Yeah, so that's doing pretty good. So this simulation, if we ran it on a slow device, would work pretty much the same. It would feel relatively similar, but a little bit jaggier. So that's the basics of how you can use how you can wire up a simulation and how you can compute delta time. Another approach that I think would be better for this particular case is just to read in the number of seconds that have elapsed and to create a constant function for your simulation. But this approach works better if you have a lot of mutable state that you kind of need to advance. I also wrote this package FrameLoop that I think is worth looking at that sort of sets up this stuff for you. So if you don't want to compute all of the DT stuff, you can just use FrameLoop, and then you just set up a callback that you want to call. So you don't have to call window.requestAnimationFrame or anything. You don't have to do any of this stuff. It'll just set it up for you. So here, I can do that just now. So we get the DT as an argument, and let's see. So then we can just call our loop function, frame loop on our loop function, and then I do engine.run and require this new module. Okay, so let's just double check. Yep. Okay, I think. Well, I know what it is. DT from frame loop is in seconds, not milliseconds. So we divide by 1,000, I think it will all work well again. Yeah, that number is much larger, so. There we go. Well, anyways, there's something else going on there, but that's kind of the basics of how you can wire this stuff up. So a nice thing about frame loop is you can set timers, so if you want to make more of a game, where things periodically happen, you have some primitives to work with, like kind of a set timeout style. You don't really want to use set timeout in a game because you probably want to implement things like pause and resume. And also, if you have a lot of things going on at once, it's easy for those timers to drift. So using a custom timer is I think, usually preferable in a game. Okay, so let's talk a little bit about 2D physics. If we're going to do simulations with SVG, I think it really helps to know how to kind of wire things up so that stuff will happen over time. So a really simple thing you can do is create some objects with x and y values, like position and velocity, and every time your loop fires, you have the delta time, dt, and you can set the position.x to be the velocity, the current velocity times the delta time. And you do that for the x, and you do that for the y, and if you have acceleration in your game, you just update the velocity by the acceleration. And anyways, you use these formulas, and then you can have a basic game running that works. So here I've got a simple SVG game. It uses this module BoxSprite SVG to set up the physics like I showed in the previous slide. So if you use that module, you can just kind of wire stuff up with like a player character that's maybe a circle or whatever. So here if we make an SVG with a ID set to be the player, then whenever we hit the key down and key up buttons for left and right, then our player will move left and right. So why don't we go ahead and wire this up really fast. So if I do xclip, xclip-o, there we go, there's our code. And I'll pipe that into main.js. Now in main.js, here's our code. We'll have to set up an SVG file in the page. So if we do var load SVG equals require load SVG, and then we'll set up this code inside of a function. So here's all the code that should be ready. So load SVG, game.svg, and function air SVG. I think that's what it is. So now we document .body.append child SVG, and we're ready. Make sense? Okay, so if we do all of that stuff, now we can make a game.svg file, and that can just be, we'll make it really big. This is a common frustration with SVGs. If you don't set the width and height to be big enough, you can't see what you're doing. Now we can make a circle with a radius of 50 and a fill color of purple, and maybe like a CX of 100, CY of 200, slash greater than. Okay, so and if we set this circle to be the ID equals player, then ideally our game should pick up on what we're doing. So let me just make sure that that is loading. Yep. Okay, so our static is still running. Whoa. So there is our circle, and I'm going left and right, and it's scrolling with the page, which is causing the jittering, but it basically works. So that's how you can sort of use some basic physics, maybe with some basic modules, to sort of wire up the basic dynamics of a game with all kinds of crazy shapes. The best part is, you can run this program called Inkscape.
Hey, James.
Yeah, I know.
Oh.
It takes a sec to load. So you can run this program called Inkscape. Takes a while to load. And you can just draw your game. For example, if I have a file like this, oh god, do I not even have it on this? Right, this is a fresh install. If I fetch that file from the internet really quickly, here we go. So I can just draw a game. It doesn't even look like the right file. I can just draw this game. So if I save that into a file, I can load it in Inkscape, and I can add all kinds of shapes. So in Inkscape, you can wire up everything, and when you click on an element, if you do Control-Shift-O, you get this option. So you can't see it very well, but the first one is ID. That is literally the ID attribute in the SVG. So this one happens to be money, and this one is player. So if we load this game file into our SVG, so if I load game.svg, if I copy that from temp, if I reload this page, here we go. That's our game, right? And now what I'll do is document.querySelector for ID player, and there it is. There's our player. So you can just draw out your game. Like, this is a really good technique for kind of arcade style games or platform style games where you want to have a bunch of different elements. You can set classes and IDs and just use the DOM to make your game run. So there's our player. We can do a nice trick. So if we save that player to a variable, we can actually make a G tag doing document.createElementNS, and then you can do clone node on your player, clone node true, to make a copy, like a sprite. Then you can remove that from the parent node. So, whoops. Clone node, you have to type it properly. So if I do player.parent node, right, dot remove child player goes away, but I still have the reference in the player variable, right? There's my player still. So what I can do is I can make a new G tag to surround the player, and then I can move the player around as I want. So if I do G equals document.createElementNS, oh god, I'm gonna mess it up. Hang on, document.querySelector, SVG. There's the XMLNS. No, it's not. This is the most annoying thing. Okay, there it is. w3.org. Oh god. Okay, that is the magical thing. You have to give createElementNS or it complains at you. So var g equals document.createElementNS, that annoying string, and then g. So now I have a G tag, and I can do g.appendChildPlayer, and I can do document.querySelector svg.appendChildG. Now there's our player again, and I can do g.setAttribute transform translate 0, 10. That moves the player 10 down. Or I can move the player to the left by 20 pixels or by 80 pixels, and there's my player, and it's moving around. So the reason why I created a new G tag to contain it is that player already had a position on the screen, so that G tag inside already had a transform if we look at it. So if you want to, you probably want to leave that transform alone because it's going to be positioned in a nice spot that you can use with Inkscape. But if you create another G tag around it, then you can set the transform property with set attribute to be whatever you want. So that's just some basic tricks that you can use to make a sweet game like this. So those are literally all the techniques in this game. You play a Wall Street banker, and your job is to collect as much money as possible, which rains from the sky. This is inspired by the music video from a musician called Disaster Radio from New Zealand. It was a really brief, it's like a really brief 3-second shot in a game. So I decided that I thought it would be fun to actually make that game for real, sort of. I mean, it's not really playable or fun, but it's kind of a basic, like the basic dynamics are all there. So if I want to take that somewhere later, it's really easy. And all that is an SVG file. I literally showed you, like, this is that game. There's a couple more sprites, but that's pretty much it. So using just few simple techniques. This is another useful trick. It's called get bounding client rects. So if you want to implement collisions, you can use these APIs. There's some more modules that are all in the notes. But that's all that it takes, pretty much, to make a simple game, to make a simple visualization, to make graphs, and all kinds of crazy, wacky, whiz-bangy things with SVG. Thanks. Question?